Now we're going to start the discussion using the whiteboard. We're going to first discuss the three-tier hierarchical model, also known as the legacy network design. What I have here are three layers. The first layer is, which is known as the axis, connected to our hosts such as PC, IP phones, wireless devices, and even local servers. We have also the distribution layer, okay, and this is where our policy and security is working, is being implemented. And we also have the core layer. The core layer connects to the router, which is also connects to the outside world, to the internet or to the WAN. Okay, now think about this, where when you are in the office, you are in corporate environment, this is what we are using. This design is good for enterprise networking, where our hosts are PCs, wireless devices, printers, IP phones, and many more. Now, imagine this. You go to the office and you connect to the network, whether it's wired or wireless. What type of traffic do you use? Okay, and where is traffic destined to? Think about it for a second. Yeah, it goes to the internet. Or even if it's not the internet, it goes towards north. It can connect to the cloud, or it can connect to your corporate data center. So this type of traffic is what we call the north to south, okay? Where your traffic is, most of the time, is a request. It can be a web request like HTTP request, and then it returns back to you, okay? For in the case of HTTP or a web traffic, you will receive an HTTP reply, okay? So that is the most commonly used traffic if you connect to your enterprise networking. Now, here's the question. Do you really need to use east to west traffic? So if you are this guy here, do you send traffic locally? Okay, east to west traffic, is it commonly used in our enterprise networking? The answer is no. Most of the time, you will use your request towards north, towards the internet. If you are sending traffic locally, that will be in few occasions, like connecting to your management device. You need to access your wireless device, your switches, and so forth. Another scenario is when you want to print or you want to scan something. That goes over your local network. Another scenario is if you have a local server, okay, like a local NFS, you send traffic or requests to that local server in your LAN environment. Here's the question. Do we scale our host, our switches in an enterprise networking environment? Let's say, can I add more switches? Yes, you can. Not only that, when you say enterprise networking, most of the time we're talking about a lot of wireless devices. Okay, I would say we have more wireless connectivity versus wired in an enterprise environment. That is fine. Okay, our networking or our enterprise networking works just fine because most of our traffic goes to north. Okay, this is what we call the north to south traffic. Now, since we've already introduced three-tier hierarchical model or our legacy network using in an enterprise network, the question is this: is this design suitable for a data center environment? Take note, in a data center environment, our hosts are not PCs, okay? We don't use PCs, we don't use IP phones, we don't use wireless devices, we don't use printers or scanners. Our hosts, okay, are just one device. These are servers. And what makes these devices or these hosts complicated is the applications running. Not only the applications, but also what kind of technology is running in our servers. Are they running virtualization? Are they running containerization, etc.? Now, what I'm going to do is I'm going to change the host to servers, and this is a wireless device. I will also change this to servers. Okay, and this will also become a servers. There you go. Now, in a data center networking environment, we need to scale, especially if your business is growing and 20 or 50 servers are not enough. You need to add hundreds of servers. Now, if you are adding hundreds of servers, that means you are adding also many switches. Okay, how many switches do we have? We have 1, 2, 3, and let's say we add up to 50. Okay, or let's just make it 100 switches because we have hundreds of servers as well. So this is 100. Okay, we have 100. If we have 100 switches, okay, because we have hundreds of servers, we have millions or 10 millions of clients worldwide. Is this design suitable for our data center environment with 100 access switches? Think about this. You, as a server, sends traffic, sends requests. You, as a user, sends traffic to a server. Let's say this is HTTP. This is the web server, right? You don't know, but our web server is not doing everything. It doesn't do all of the process. It needs to communicate to other servers as well. So this is the web servers. Maybe he needs to communicate to an API. Okay, maybe he also needs to communicate to a database server, or this API also needs to communicate to a caching server. Same with the web server. Okay, needs to connect to a caching server or a messaging server, or this guy here needs to communicate to another server which is doing the messaging and another API, and this server right here needs to pull another information, another database. Okay, so the idea here is that we are doing a lot of things and you don't know everything because it is behind the scenes. Everything is working in the background. Okay, and since we are not a full-fledged programmer, I don't know with you, but I can program, I can do scripting, but I'm not a software architect who knows everything that's running in the servers or in our data center environment on the software side. Okay, and it can be also very complicated if it needs to communicate to a security appliance or analytics server or a containerization and other things going on in our DevOps environment. So the point is there's a lot of communications going on. Okay, now this is what we call east to west traffic. East to west. Lateral movement, also known as host to host or server to server communication. In a data center environment, especially in a large data center environment, this is at least 80%. Okay, and more or less 20% for the north to south traffic, which is requests connecting to the web and reply connecting back to you as the user. Here's another question, okay? Or let's go back to the original question. Is our three-tier hierarchical model, okay, or our legacy design suitable for a large data center environment? Think about this. If we are using 100 switches, do you think this distribution layer is enough? Okay, we scale up to 100 switches, right? Our distribution switches is in this drawing is only 2. Okay, can we scale this? That's another question. Can we add more switches in this layer? Let's say the third and let's say the fourth switches. Okay, if we do this, guys, what's gonna happen is you're going to have more interconnect. Okay, and maybe the STP will kick in because we have a lot of interconnect. There's a lot of redundancy, and we already know that STP block ports. Okay, and this is what we want to avoid in a data center. We don't block ports. Okay, so really STP is not really a good design in a modern networks. So the another question is, what are we currently using? Well, the more common scenario is we make this 2 switches up here. Okay, we call this MLAG in an open or in a standard environment. In other vendors, they call it VPC. And the idea is to make these two switches, okay, under the distribution layer to act like one logical device. And the idea is this switch here, the first switch, would send upstream traffic simultaneously on both distribution switch 1 and 2. This is good, but again, the question is, can it scale? Can we add the third and fourth server? The answer is no. This solution, the MLAG or the VPC, is only good as two switches. It's only good for a pair of switch, and it's not designed for a large-scale environment. Now, going back to the problem, if we can scale our access switches up to 100 switches, while the distribution layer can only do two switches, what will be the effect? Well, the problem is 100 versus 2, that is mismatch, right? You will experience bottleneck to our distribution layer, and this will lead to congestion. Okay, so in short, our legacy or 3-tier hierarchical design is not good. It's not perfect for our data center environment, especially for the large one.